One of the things that we've talked about before is the notion of the expected value for a probability distribution. And we noted that the expected value of the random variable is the same as the mean for that random variable. But what we haven't talked about yet is the standard deviation of the random variable. So let's look at a probability distribution, and we'll just look at something very simple here. Let's suppose that we have the values 1, 2, 3, and 4 that the random variable could acquire. And let's suppose that their respective probabilities are 0.2, 0.3, 0.3, and 0.2. And we verified that we have a valid probability distribution by noting that each one of these probabilities is a valid probability. It's between 0 and 1, and that their sum is 1. They add to 1. We remember that the mean for a probability distribution is found by adding up a bunch of terms, and those terms consist of the products of the values of the random variable and their respective probabilities. So in this case, we'd have 1 times 0.2 plus 2 times 0.3 plus 3 times 0.3 plus 4 times 0.2. That's what each of these terms represents. And so we'd have 1 times 0.2 is 0.2 plus 0.6 plus 0.9 plus 0.8. And that mean is going to turn out to be 2.5. Now that seems reasonable also because the probabilities, although they're not equal, they are balanced. They are symmetric here. And so we expect that the mean for this random variable is going to be between 2 and 3. And it is, since they're exactly the same on both sides, since it's balanced, it is going to be right directly between 2 and 3, or 2.5. Now the standard deviation for a probability distribution is found, just like always, we're going to find the variance first. And the variance is found by this formula right here. We're going to add up the squares times the probabilities. So in other words, we're going to square each data value, multiply those by their respective probabilities, add them up, and then subtract the square of the mean, so the square of what we just found. So I think what I'm going to do is I'm going to make another row here. I'm going to call it x squared times p of x. And that'll give us a little something to look at here. So 1 squared times 0.2 is still 0.2. 2 squared is 4 times 0.3 is 1.2. 3 squared is 9 times 0.3 is 2.7. And 4 squared is 16 times 0.2 is 3.2. So this value then is going to be the sum of all of these values, which is going to be 7.3 minus the square of the mean, so minus 2.5 squared. And so we're going to have 7.3 minus 6.25. And so this variance is going to be 1.05. And so the standard deviation will be the square root of 1.05. This will be approximately, because this is going to be an irrational number, this will be approximately 1.0247. But what we're going to want to do is round this thing appropriately. Now our data values are the values of the random variable, and they are whole numbers. So when we report this standard deviation, we would report it as 1.0, one more decimal place than occurs in the raw data. So there is the mean, 2.5, and there is the standard deviation, approximately 1.0.